Hello, in this video we're going to go over the Active Directory key components. This is primarily for Pentesters taking the OSCP and the CRTP, but in general, if you're very new to Active Directory, this video will be a really good introduction for you. If it's something you're not familiar with, this is going to introduce you to the key concepts and just things you'll need to know about if you're starting out. So key takeaways from this, what we're actually going to learn: understand the key structure and components which make up an Active Directory structure, how Active Directory domain services is formed. It does not cover attacks in this video. That is going to be the next set of videos going over specific attacks for specific parts of a domain that we mention in this video. And this is the theory side of a practical demonstration. So as well as an attack-based video, I'll also be putting out a video of how things are managed and created inside domains. There's plenty of videos online, but I'll be doing my own, so it's a bit more accustomed to this video. It links in nicely. So what is ADDS? So Active Directory Domain Services is a hierarchical structure, centralized store. Basically what that means is that everything is sort of managed by sort of one machine or very centrally. A lot of the utilities for management, as we're going to cover, such as GPO, things like that, it's all managed in one location and pushed out globally across it. Developed by Microsoft, it's proprietary software. It utilizes LDAP to provide its functionality. So if you think about Active Directory is more of a database, a management system. LDAP is the protocol which allows all of this to come together and provides functionality to this database. Essentially, it's like a driver for your if you're more of a software developer. If you think of MySQL being your database, then you have different drivers to connect to that database for different languages, things like that. It utilizes Kerberos, its authentication mechanism. I've already done a video on Kerberos. It'll be uploaded at the same time as this, or a few days before, a few days after. I'll link all these in the description. So all these sorts of sets of videos related to Active Directory are going to be uploaded at the same time. So if you just have a look through my channel, they're all going to be there. I'll also leave some other resources as well, such as MSDN articles and another really good video on Kerberos as well. And the objects stored inside of an Active Directory domain include users, groups, and computers or services. So computers and services are interchangeable. Or they're not, but for this we'll say the same thing. So obviously a service is going to be on a computer, but a computer necessarily doesn't need to have a service. But those are the three primary things that you're going to be interested in and find within a domain, the three physical things. So right away, LDAP, what is it? It stands for Lightweight Directory Access Protocol. Clues in its name. It provides access to directories across the network. It operates on both TCP and UDP ports, 389 for non-TLS and SSL connections, and 636 for LDAP-S, LDAP Secure, SSL. It's a vendor-neutral protocol to provide an interface to look up information and devices within the network. So if you think of, again, as Active Directory, it's proprietary software. It's just generally going to be used in Microsoft systems, or it's going to be heavily reliant on Windows and Microsoft integrations, whereas LDAP, that is not the case. It can be used across a variety of systems and a variety of networks. It's non-proprietary, anything can use it. That's why it's quite a lot of the time you'll find it in systems like authentication, it'll be plugged in with it. It's just sort of how it comes together nicely. ADDS is similar to a database. It stores the information. LDAP is the functionality allowing that data to be accessed. So as I mentioned earlier, Active Directory Domain Services is just a setup like a database where everything is stored, and LDAP is just going to provide you the access to that data. So the general structure of a domain, really simple. We're going to go through this slow time, so it should hopefully be nice and easy to understand. You can take notes, and there's not too much to bog you down, too much useless information. The hierarchy top down. In a domain, we have sort of three physical structures, if you will: forests, domains, and trees, and organizational units. We are going to discuss these at greater detail as we go through this. Just a quick one, sort of forests are your topmost sort of thing that surround everything. Inside a forest, you can have domains and trees of domains. And then inside domains, you can have organizational units, which are just sort of subcategories, if you will. It'll all be explained through it. It's better explained through a diagram. General structure continued, and the objects in the domain are going to be managed by your ACLs, your access control lists, GPOs, your group policy objects, and trusts. Trusts don't necessarily manage those things or control them. They're just more of a relationship which allows data to be accessed in different ways, or allows otherwise inaccessible data to be accessed, or resources, if that makes sense. Again, we'll cover all this. So if you're very new to this, it's going to sort of boggle your mind. If you're coming from the OSCP and you're actually, this is the first thing you're seeing about Active Directory, or you're thinking, oh Christ, it's a lot to take in. It is, but the more you look at it and the more you sort of look at things, it is going to come together. I highly recommend you watch other videos as well and do a lot of reading until it clicks. So for me, I have to read things over and over, find what works for you. These materials that I make for you lot help a lot as well for me. So maybe try that, try teaching other people about it, and that might help you understand a lot of this a bit more. Also watch other videos as well, how an Active Directory system is actually built, and that will also really help you. And in general, when you get more lab time as well from attacking machines, or if that's not your goal, if you're more of a sysadmin, the more you build them, the better you're going to get, the more familiar you're going to become with the system. So here in front of us is the general physical structure of an Active Directory domain. This is obviously a very simplistic diagram, but it's just as an example. That can obviously get infinitely more complex than this, but just as a basic understanding, we're going to go over the three main physical components. So this doesn't show one of them we've just discussed, the organizational units, the OUs, but this does show the main sort of building blocks. So if we think of or if we go in the size, going in order of size, if we use a box, this is a bit of an analogy. The largest box in this case would be our forest. Inside of that would be a medium-sized box, in this case our domain, and inside of the medium-sized box would be an even smaller box, which represents our organizational units. In this case, I've already said it only shows our domains and our forests and our trees, which I'm going to go over now, but it's just so it's a bit easy to understand. So, forest can contain multiple domains, and these obviously listed here, domain 1, domain 2, can be any different things. Let's say it's two parts of an organization, like sales and admins, for instance. The setup isn't really relevant here. It can be anything. There's different schemes for that, but in this case, it's just out of scope of this. So as you can see, actual forest can contain multiple domains. Forest is generally just our big scale, the largest sort of element in the domain that you're going to get, like the biggest container. Domains are just another smaller container inside that. And again, as you can see here, the trees. So an individual domain is just as it is, just itself. A tree of domains is just a domain with then sort of namespace attached to it, or sort of child element. So obviously our parent domain here is domain2.com, or in this case domain1.com. The child domains of that are sales and accounts, or they continue the same namespace, but these are all connected and linked, and that'll be called a tree, that's the domain tree. So sales.domain2.com and accounts.domain2.com, these all form a tree, just like this over here forms a tree. And these domains, obviously the root here, altogether it forms as part of a forest. If that's a bit easy for you to understand in more of a physical layout structure. So forests, it's the highest node in the hierarchical structure. It can contain multiple domains, as we saw there. I do not believe there's a limit on how many can be per forest. I'm sure there is a theoretical limit, but I'm not aware of it. It's used as a security boundary, containerization. So the idea of forests is obviously, or like anything, separarization, like abstraction. It's more of a security concept, and as well, it's good for organization, but it just keeps things away that don't need to sort of necessarily connect or be together. It keeps them containerized. They can only access specific things. And multiple forests can exist and communicate via trust. As you can see here, there is a trust relationship. This is a domain trust, not a forest trust, but as well, trusts can operate or exist between domains and forests, respectively. I'm going to go over that a bit later on as well. Domains. So all domain is a collection of organizational units. So domains are the second in the hierarchy. They are the second largest part of a domain. You can have multiple domains in a forest, as we've already covered. It's a container for users, groups, machines, and services, etc. So in general, to simplify it, it's just a container for all your organizational units, and inside those organizational units can contain users, groups, machines, services, and pretty much everything else you're going to have in your Active Directory system. It can form a tree where multiple domains share the same namespace, e.g. co-op.local.com, admin.local.com, as we've just seen here as well. So trees, made up of multiple domains which share the same namespace. Domains in a tree are also linked by trusts. This is inherent. It's not something that you have to sort of do. It's just it just happens. It occurs. It's by default. That's how it works. It'll have a particular trust attached to it. And the first domain is known as the root domain, and the child domains will follow. So obviously in this case, the root domain would be domain 2, and the child domains of this would be sales and accounts. So here we've got just another example of a domain tree and just sort of how things can go. So as you can see here, the root domain is acme.com.tw, and then obviously we have some child domains, and then we have even more child domains off this middle engineering.acme.com.tw. Of hardware and software. As you can see, it's been even more containerized or separated there. So organizational units. This is the smallest object in the hierarchy, and it is a container which consists of users, groups, and machines. So a domain will store these things, well, an organization unit will store them as well, but this is where they are actually stored, is in like the physical hierarchy. Domain obviously contains everything. The organizational units are what keep them. So your organizational unit could be like maybe sales or admin. It's just sort of a way to, as it sounds, organize things, like a directory structure to keep things simple. So the domain itself could be maybe a company, as in like, I don't know, company1.com or something like that. Inside that domain, your organizational units, you've got managers, you've got your sales representatives, you've got accounting, things like that. That's how an organizational units will work. And then inside of that, you've got computers which are attached to your sales, your accounting, and then you've got your users which are attached to each, things like that. Just really quick before we continue on to the next bit, this is just covering the physical structure of a domain. It's not very in depth. It's just more of a sort of an outline for you to keep it nice and simple, so you get a nice understanding of things. If you are absolutely very new to Active Directory, I should probably mention this prior. Sort of the physical layer of it, obviously the domain controller is what controls everything, known as the DC. This is where all of this will be sort of set up, and then it'll be pushed out across the domain. So the DC will hold all this information of what is what, your forests, your trusts, etc., etc., and it'll just be sort of mapped out across your network. What we're going to discuss now are how the domain is actually managed via its policies and things like that. So how access and permissions are managed for an object. This is in relation to everything on Windows, not just Active Directory, but it's all very similar, but we'll cover that for this. So in general, how access is actually managed for objects in Active Directory is by an ACL, an access control list. An ACL is a list of ACE, access control entries, defining which trustees have an access to an object and what access they have. By trustees, I just mean which users or groups have access or do not have access to an object, and it says there what access those particular groups and people will have. ACLs are also used for auditing, tracking who accessed and how many times. Like, so for instance, if you've unsuccessfully accessed a certain resource, so it's just like tracking who's accessed what, how have they accessed it, success or fail. That's also what access control lists are for. They specify what things should be logged and audited, and how it should be logged as well. It uses security descriptors to define what access a user has, and security descriptors contain security info over securable objects. A securable object is just any object with a security descriptor. So any sort of thing that exists, if it's got a security descriptor attached to it, it is then defined as a securable object. If it doesn't have a security descriptor attached to it, by default, it just grants full access. We're going to go over all this now. It's a bit more in depth than what it needs to be, but it's just more it's good to know really. But again, it's not too particularly relevant, but hopefully it'll understand a bit better. So security descriptors. It contains security info associated with securable objects, and any securable object is just an object with a security descriptor attached to it, and the security descriptor will include the following information. The SID, the security identifier, for the owner and the primary group of an object. A DACL, specifying access rights of users and groups. We're going to go over that in a second. And an SACL, specifying what types of access generate which audit records. And the last part of a security descriptor is the control bits, which qualify meaning of the security descriptor. So as I said there, the ACL is used for auditing and access control. These two things here, the DACL and the SACL lists, will specify different things. Your DACL is for what access people and groups have, and your SACL is specifying what auditing capabilities to be performed on this object. Basically, if there's no entry in your SACL, no auditing will be done. So ACEs, access control entries. It defines what access a trustee has over an object. It contains 3, although 5 do exist, but these are sort of the default 3 you're going to get. Specific access rights. They are denied, allowed, and audited. So an ACE in your DACL list will be obviously user allowed to access and then user denied, things like that. And then if it's an audited ACE in there, it just means every time this is access, we're going to do put it to system log or things like that. An ACE is made up of 4 key parts. The security identifier, same again, but this time it's the SID of the actual trustee the ACE applies to. So it'll be the SID of the user or the SID of the group. An access mask, specifying rights over objects. Example there, 777, so obviously all rights. That's what I was trying to get to before when I was talking about a security descriptor. That's essentially how I just sort of broke it down. That's all this really is. It just sort of defines who can access what and how they can access it, kind of thing. Like this access mask here, that kind of thing. A flag indicating what type of ACE. Don't know what those flags are off the top of my head, but it'll be one of those 5, or in this case one of those 3, either denied, allowed, or audited, or there were 2 more. I can't remember what they were. And it can also have bit flags saying if child objects inherit the ACE from the primary object. All that means is if you've got an OU or whatever it may be, as some sort of secureable object, if child object if that object has child objects, will it inherit the ACEs from the parent object or not, or how will it react to them, basically. Here's more of a diagram, so it's a bit easy to understand. So as we can see, in here we've got, obviously I know it says here we've got 4 key parts, but obviously this is just it's part of its structure here, the size as well. So there's our access mask, our security identifier. These are obviously ordered in size as well. So obviously we've got flags, which are just bits, and again type, which is just going to be bits as well, very small in size. Our access mask, off the top of my head, again, couldn't tell how much that's going to be, but it's going to be quite a few bits. And the largest sort of actual bit size is going to be our security identifier, because it'll be, again, can't tell how many bits exactly, but it'll obviously be a nice long number, or GUID, so that's hence why it's a lot larger. Finally, the ACLs, the discretionary access control lists, and this identifies trustees that are allowed and denied access to a secureable object. When a process attempts to access secureable objects, the system checks the DACL list for a specific ACE to see if access can be granted. So rather than checking if it can't be, it'll see if it's there, and then obviously by default, if it's not there, it can't be done. If an object doesn't have a DACL, full access granted, and the system checks the DACL in sequence until access is allowed or denied. So all that means is it'll just go down the list in an order, or whatever order they appear. And if it finds an ACE that's relevant, if it's denied or allowed, then you'll be allowed or denied access, depending on what user, things like that, what they're trying to do. Again, it's always good to have a nice little diagram. So this is more from a kernel perspective, what the kernel actually sees when it performs this sort of thing. So again, the ACLs and ACLs, things like access control lists and ACEs, this all goes back to Windows kernel. This is just how Active Directory sort of plugs into Windows and uses it, but it all works on the same system, so we may as well explain it. This is just representing AF2 processes we're trying to authenticate. So as you can see here, we've got our DACL list for an object, whatever it may be, a file system. As you can see here, ACE1, our user Andrew is of the permissions read, write, and execute. He ain't allowed to do any of them. ACE2, Group A, access allowed, and everyone else, if you're not in Group B, if you're not in Group A and you're not Andrew, you're allowed to read and execute. As you can see here, thread B, Jane is a member of Group A, so she's allowed access, she's got write access. Andrew, he's just denied access. He's obviously part of this group, but he's just straight up denied. It just overrides it as he specifically denied access to it rather than his group. So further to that, as I mentioned before as well, ACLs are also used to audit, and this is where the system access control list comes in. And this contains ACEs which specify which types of access will require logging and auditing. So basically all that means is if an ACE is present in this, it'll basically say something like, upon access log that this file has been accessed in the security log, things like that. It can also specify where it's going to show up, I believe, as well. It'll generate audit records upon access, failure, access, success, or both. So you can get it to, if you want it to log when someone successfully accessed the document or they've been unsuccessful or both. So just to keep track if it's a really secure document, things like that. And it stores logs by default in the Windows security log. So confirmation of ACLs, I'm pretty sure I understand that was pretty thorough, but it's good to understand they're a good avenue for abuse. Basically, it's just policies over objects, and obviously, if you can control an object, there's generally some good things potentially might come out of that. So ACLs are access control lists, which contain ACEs, access control entries. DACL and SACL are a type of ACL for different purposes. So obviously your SACL, your system access control list, that is going to be for your auditing. Your DACL, your discretionary access control lists, are going to be for your access rights. Active Directory is a proprietary software but built upon the Windows kernel, and it utilizes a lot of inbuilt functionality. So this is not reinventing the wheel. ACL, things like that, it's not part of Active Directory, it's part of Windows. ACLs contain who can access what and what access they can have. Technically, that's ACEs, obviously, access control entries, but the ACLs obviously do contain the ACEs. So, yeah, well, there we go. Just before I forget, I'm really quickly just added this in. I'm just going to go over security descriptors again, just to briefly go over them. So, as I mentioned in here, how I sort of remembered security descriptors is essentially sort of like the bit mask for Linux permissions. They are not the same. The security descriptor is a structure of containing the SID for the owner of the object, the securable object, the group of the securable object, the ACL list specifying what permissions they're allowed, and the system access control list. So just auditing access, seeing who's accessed it and when they've accessed it. I remember it like this, even though that's technically incorrect, but it just helps me remember it's whatever works for you. Not that you need to remember it, but it's just a little thing there, just a bit more extra information for you. So obviously any object in Active Directory or in Windows that is a securable object, it will have a security descriptor. Okay, so now we are on to GPOs, the Group Policy Objects. This is a thing that's been around since the early days of Windows, and it basically just allows for centralized administration. As it says there, it allows for ease of administration. This basically just means that the centralized management, so when an admin will push an update, instead of having to do it manually on every machine or every single system, it just gets pushed once from a domain controller, and then it goes across the network, and it's put onto different machines. It takes a bit of time, obviously, but eventually those settings will reach everywhere on the network. So, collection of policy settings for both computers and users alike. It has a unique GUID-based name, and it represents both policies in the local file system and in the Active Directory. What it means is, obviously, GPOs can affect files on the local system and in general for Active Directory, whether or not you can access resources on the network or other machines, things like that. This is how a GPO is structured, so it contains both users and machines relevant information there. Every GPO has two parts, a computer node and a user node, as we just saw there. Active Directory GPOs are all stored on DCs, domain controllers. They're all in like a nice big list, so you can go through them if you really wanted. They've got some funny names, but you can sort of link what they are through enumeration scripts, and you can resolve what they're going to do as well. Computer policies specify system behavior, app settings, security settings, assigned. I'm not too sure what that's referencing there. Startup and shutdown scripts. So this is just what behavior that you're going to get when GPO is specifically for a computer. I'm not too sure what I meant by assigned there, but yeah, oh well. Then user policy specifies system behavior, app settings, security settings, and user logon and logoff scripts. So basically, when a machine is shut down and started up, the computer policies will specify certain scripts that are done for that, and then the user policies will specify what logon and logoff scripts are done, among other things as well, as it says there. So app settings, security settings, what app settings can be run on a certain computer, what apps can be run on a certain user account, things like that. That's what GPOs are used for. Computer settings override user settings. So, for instance, if an app is disabled by default on a user and then a computer enables it, I believe that, well, in theory, that user should be able to access that app on that machine. GPOs can be linked to sites, domains, and organizational units. We haven't discussed sites, but sites are just, if you think of them as more, well, an actual physical thing. If you've got an office in another part of the country, so let's say you're in one part of America, like, I don't know, California, and one of them's in Washington. Those two sites would be basically replicated domains, so users at each site can then access the same account from the same place, and you haven't got to go all the way. Let's say if you're in Los Angeles, you haven't got to all the way go go all the way to Washington to access it, they'll have a domain controller on site or closer to them. That'll mean they can access that data a lot faster. It basically just speeds up the process. Multiple containers can be linked to the same GPOs. One container can have multiple GPOs linked to it. So there's not really a limit. GPOs can be linked to one thing, or multiple GPOs can be linked to multiple different things like that. The same things can be linked to another. GPOs linked to a site applies to all users and computers in the site. A GPO links to a domain applies to all users and computers, and via inheritance to all child users and computers in child objects. Organizational units. So basically, any GPO that is sort of links to a domain, it'll inherently by default apply to all users and computers, and then all child sort of elements of them as well. A GPO applied to an OU applies to all users and computers inside, and all users and computers in the child object units as well, unless specified otherwise. The policies are not inherited across domains, so if on one domain the policies will not go to child domain, you also have separate policies applied, things like that. Confirmation of GPOs. It's a centralized management system for policy changes to be pushed across an AD environment. Abuse can occur there, not discussed about in this video, but obviously, as I said, there's a bit of a delay with it. So potentially, if a policy is not quickly enough, if the security policy is not pushed in place quick enough, things like that can lead to certain attacks if obviously things aren't corrected quickly enough, things like that. GPOs are objects which contain policy settings which can apply to one or more multiple users and computers. There's multiple avenues for abuse due to incorrect misconfiguration of privileges. So finally, now we're going on to trusts. Trusts are just a defined relationship between domains or forests, not both, one or the other. That says there, trust relationships can occur between domains and forests. We'll talk about them all. So trust can occur between domains in a few different ways, and trust can occur between different forests in generally one way, but we'll talk about that. Trusts exist to define access to given resources across physical boundaries. So obviously our domains and our forests are the physical boundaries, and these trusts enable us to access resources in each, or maybe one of them, depending on the access type you want to give. And different types of trust exist to grant different types of access, which we're going to go over now. So these are the main types of trusts you're going to come across. There are a few more, or I say a few more, probably one more, and depending on if you want to get pedantic, a few of the different types. I've covered most of them here. If you want to have a quick look on MSDN, look at realm trusts, things like that. But these are the main ones that you're going to come across and probably going to see throughout your OSCP or CRTP journey. Real world, obviously, you're going to want to know anything's possible, so have a good look. But these are the main ones you are going to see, just to keep things fairly simple. So obviously we have unidirectional, bidirectional, external trusts. This is sort of the type of trust we can have, being transitive or non-transitive, which we're going to go over in a minute. And then intra-forest trusts. These are all pretty similar, so I've just put them into their own little category. So we have their parent-child trust, tree-root trust, and shortcut trusts, which we're going to go over in a minute. So starting off with unidirectional. It's also known as a one-way trust, obviously uni being one. So the users, so for instance, users from domain A can access resources from domain B, but users from domain B cannot access resources from domain A. So unidirectional trust, or how a trust relationship is established, is one domain will trust the other. One is a trusting domain and one is a trusted domain. So unidirectional authentication path and unidirectional access path, trust auth goes one way and the access goes the other. I've got a diagram to show this because it sounds a little confusing. It's a lot easier in a diagram. I'm going to go on to that now. But that's how it works. So one trust will give access to the other, and then the other trust will be allowed access back to that trust. That's sort of how they work. The trusted domain is allowed to access. The trusting domain's resources. So here we go. I believe we've got this off MSDN or Google Images, one of the two. So as you can see here, the trusting resource domain. This is the resource that you want to access. This domain is saying this other domain here is if this was domain B, this was domain A, this was domain B. So, for instance, domain A is saying domain B is trusted to access our resources. So by inheritance, domain B can then access their resources, but there is no definition of trust for from domain B to domain A. So this direction of access only goes one way, and the direction of trust only goes one way because only one domain is trusted. If that makes sense, it's pretty pretty simple here. I think if I try and go into it too much, it'll probably confuse people. But if you need to, just pause, let's have a look, and then go back over. But all relatively simple, nothing too major here. Then we have a bidirectional trust, also known as a two-way trust. So both domains in the trust can authenticate to each other and access each other's resources. So now this would be basically two one-way trusts. So instead of having just one of these, we'd have another one, but in the split direction. This time the trusted domain becomes the trusting domain, things like that. So both domains in the trust can authenticate to each other and access each other's resources. All domain trusts in a forest are default two-way transitive trusts. So what that means is if a new domain is created, whether it's tree root or parent-child, things like that, by default they're always going to be two-way transitive trusts. They can always talk to each other, and then the trust will extend. Child domains automatically create a two-way transitive trust between the child and parent domain, and think of it as two oppositely facing one-way trusts. A bit of an easier diagram, as you can see here. A trust has been developed between domain A, and then a trust has been developed from domain B, which inherently allows both of them to access each other's resources. Then we have external trusts. So these are just trusts that for domains that are in different forests, essentially. So these are non-transitive, and they're made between two domains in separate forests, or between an Active Directory domain and a Windows NT4 domain. I wouldn't worry too much about that bottom one. Obviously, Windows NT being quite an old system, but just a little note there for you. So transitivity between trusts, we've mentioned it quite a bit. We're going to go over it now. So transitivity is extending the trust between the two domains in which it was formed. So generally, a trust is only going to be formed, or can only be formed with two entities. One of them trusting the other, or either of them trusting each other, kind of thing. All that means is transitivity just refers to the trust being extended between the two. So if we have domain A and domain B, we've got a trust between them. If domain C was created, by inheritance, there is a link between domain A and domain C. If the trust is transitive, domain A gets access to domain C's resources. If not, a non-transitive trust, we would not have inherent access to domain C. We'd have to establish our own trust. So transitive trusts flow upward through the domain hierarchy. What that means is, obviously, if we start at the bottom of the domain, we'll go up, so domain C to domain B, domain A. If a trust is non-transitive, it means the relationship is not extended to other domains, as I already mentioned there. Finally, the example I've just mentioned, a bit better if I wrote it down beforehand. Domain A, B, and C in this example. Domain A trusts domain B, and domain B trusts domain C. A transitive trust would mean, inherently, domain A trusts C, whereas a non-transitive trust would deny this access. So basically, it just means that if something's non-transitive, this trust is not going to extend, and we must form another separate trust to access resources. Here we go. It's always better with an example. So here we go. Domain 1, 2, and 3. A two-way transitive trust by default, so these domains trust each other, can both access resources. And then domain 2, another transitive trust between domain 3. So these can both access each other's resources. And then because of that, we've got access to this domain here. Inherently, that trust means, or these trusts that are transitive, it means that our domain 1 has access to domain 3, and vice versa, that kind of thing. Finally, intra-forest trusts. So transitive trusts only used in a single forest. So by default, when you create any domain in a single forest, it's always going to have some sort of two-way transitive trust. So a parent-child when a new domain is added to a domain tree, as we've already spoken about, that'll have a two-way transitive trust. A tree root trust, its default behavior will be that a two-way transitive trust is created when a new domain is added to a domain tree. And a shortcut trust, this is just a trust that will improve speed for authentication, things like that. By linking domains in separate trees within the same forest. So obviously, if your domain's not in the same tree, it is going to be a little bit slower for things to get across the network. But if we create trust there, it creates a simpler path for things to go down. Think of it like electricity, or probably overcomplicating a little bit, but obviously electricity is going to take the shortest path. Same way here, or same principle applies here. The shortest path to it would be the shortcut trust, so it's going to take that. And then finally, forest trust. So not a great deal to say here, but this is just between two forest root domains, so between two separate forests. It can't be extended to a third forest. A completely separate trust has to be made, so only can exist between two, and can be one or two-way transitive. They can't be non-transitive just due to how it works. So if we look here, we have three forests again. There's a forest trust established between these two, and if we want to get between all of them, sorry. So by default, forest 2 can access both resources in forest 1 and forest 3. However, forest 1 is not allowed to access resources in forest 3, and vice versa. If we want to create access, we're going to have to create our own trust down here and go from forest 1 back to forest 3, that kind of thing there. Some further structures to be aware of, just in Active Directory real quick. Containers. It's a basic physical structure for organization, and by default, you're going to get it for your users, container, and computers, things like that. I like to think of it as an organizational unit with less capabilities. Organizational units offer more control and more security. For me, there's no real reason to use containers rather than organizational units. One of them can be a lot more controlled and secured, whereas containers cannot. A schema, it's a set of objects and types that exist within an Active Directory environment. So that's it. Every object that exists will have a definition and class somewhere. That is what the schema is. It stores all that information there. And finally, the global catalog. It contains partial replicas of every object that exists in the domain. And this basically allows users to find common objects quickly. It reduces search times massively by storing partial properties or commonly searched properties that maybe not the distinguished name of the object, just things that people are going to type to find things. And then Active Directory can look here, and if it exists, which it generally will, really reduces search times. Obviously, this don't cover absolutely everything in Active Directory and a lot more other things as well, but these are the main ones that you're going to just sort of want to be aware of and that you're going to come across. Finally, it's worth mentioning NTLM authentication. I'm not going to absolutely beat it to death, but basically this is just an old authentication protocol which is still supported by Active Directory environments. It is getting phased out. It probably won't get phased out for at least a number of years yet because it is supported by default in every single Active Directory environment. It's being phased out as 2024, but it's still heavily prevalent in most environments. Most sort of commonly, it's vulnerable to man-in-the-middle attacks. So if you want to do some sort of relaying attack or capture the hash, things like that, this is still very much exists for this authentication protocol here if it's enabled, which it most likely will be. And finally, just going over some resource, some reading material for you. So a lot of the stuff I've got from this video is heavily reliant on MSDN. So if you want to go, I'll leave this link in the description as well. Have a read on there. As well from the CRTP and all the security. Not too much from the OSCP. I think, I didn't use a lot of barely any resource in there. I learned a lot of it beforehand, as I already mentioned in my OSCP video. So I can't give specific credit there, but the OSCP is going to cover some things in there as well, but not a great deal. And finally, all images provided by Google Images. If you've made it this far, just really quick, please subscribe, please do like, comment, everything you need to do. It really does help the algorithm. 95% of people, they're all male, you're not subscribed. So if you've made it this far, I've probably helped you out or at least enjoyed something, you've got something out of it. Please do subscribe. It really does help the algorithm. Thank you very much for watching. More videos to come. The next set of videos after this will be covering actual physical attacks on a domain in a Active Directory environment. So stay tuned for them. They'll be coming out. Once you see this video, they'll probably be coming out either the day after or within the following week. Thank you very much.